Okay, so this is basically another example based upon the previous problem where we build a circuit diagram based upon a state diagram. So here the state diagram is actually not shown, but consider that in your question there would be a state diagram and you would be building the state table based upon that state diagram, and consider that in that state diagram the output was mentioned. So that's why here we can see a separate column for the output. So this would be the state table for that state diagram. Okay, so consider this is the state table, and from this state table in the next part what you will do, you will create the flip-flop inputs. Okay, so in this question you are supposed to build the circuit using D flip-flop. So consider that we can actually understand from this state table that there were 4 different states in the state diagram. So that means we'll need 2 flip-flops, right? So 2 to the power 2 number of states, so we'll need 2 flip-flops. Okay, so 2 D flip-flops, and to distinguish the inputs among them we'll just consider them as DA and DB. Okay, so we'll insert 2 new columns, DA and DB, alongside this table, and then we will fill up DA and DB based upon the excitation table of D flip-flop. Okay, so this is the excitation table for D flip-flop. So let's consider the first row here. So when we calculate DA, we'll only take into consideration A plus and A, okay, not anything related to B. And when we will calculate DB, we'll only consider everything related to B, not anything related to A. Okay, so for DA, here we can see the present state and next state, A and A plus, the values are 0 and 0. So we go back to the excitation table and we find out present state and next state 0 and 0, and we see what the input value is. So the flip-flop input is 0. Since the flip-flop input is 0, so we write down 0 here. So let's check out another random row. So here the present state is 0 and the next state is 1. So we go to the here the present state is 0 and next state is 1. So we go to the excitation table and we find out this specific combination, present state is 0 and next state is 1, and we see that the flip-flop input is 1. Alright, so here we can just put down 1 as the flip-flop input. So this is how we can fill the whole column for DA, and we can do the same for DB based upon B and B plus and the excitation table. So once we're done with both the flip-flop input columns, then we'll figure out the K-maps. Alright, so again we'll build K-maps only for the flip-flop inputs and the external output if there is any. Okay, but in this question there is definitely an external output, which is Y. So we'll definitely calculate the K-maps for flip-flop inputs DA and DB and Y. So here are the K-maps. The inputs would be present states and the external inputs, so A, B and X. So just build the K-maps, find out the equations, and once you get the equations you can just draw the circuit like the previous problem. Okay, so this is another example of how you can actually build a circuit diagram based upon a state diagram. Hope you understand. So thank you everyone.